Semester Project 2, Transitioning from Water to Land. Environmental changes. There were a variety of changes happening during late Devonian through early Carboniferous period that enabled aquatic animals to transition from water to land. During this extraordinary time, animals began shifting from living in purely aquatic realms and had set a stage for early tetrapods to transition to fully terrestrial animals. During this evolutionary period, Earth underwent drastic changes that supported the current living environment. Continents began to shift, changing ultimately into a big continent Pangea. There was sharp decrease in carbon dioxide levels, lots of emerging tall forests, a variety of arthropods occupying the land. Those were the changes that were happening in environmental changes from animals to be able to move from water to land, affecting the change. Skeletal adjustment as animals move from water to land. So now, up until now, animals are primarily living in water. They rely on full body support from water and their buoyancy without any much of downward force, and they use their tails to generate thrust. So when they transition from water into land, there are several challenges for them right now, because now they need to rely their full body support, and they have to be able to move efficiently onto land. So several key evolutionary skeletal and locomotion adjustment had to come about, and they're seen in early tetrapods. The developments of limbs that acted as body support from underneath the animal's body. We see expansion of thoracic cavity to support further lung development, and we see a change in bone structure from laminate, dense from the outside, into cancellous, spongy inside. Those were the distinctive adaptation and crucial elements for the animals to obtain to move from water to land. Porolethimorphs, members of this extinct group of first lobe fin fishes such Ostilopemorphs and Elpiostegeids are considered stem tetrapods. Their characteristics show first early transitions from fins into limbs. Although still primary only aquatic, they were able to move above water into land thanks to the characteristics such pectoral fins appearing to look more like limbs. They were connected to the chains of bones, ultimately laying evolutionary foundation to shoulder girdle, which aided in their bodies to lift up and move from the sediment into the land. Tiktaalik. Recent discoveries of fish-like, stream-like tetrapod Tiktaalik improve our understanding of fin to limb transition. So Tiktaalik considered the first transitional form of aquatic animal into terrestrial animal. Tiktaalik retained some of the aquatic characteristics from fishes such fin rays and gills, but also gain new adaptive traits that set the foundation to be developed into more developed tetrapods. Key transitional adaptive features: lost bony operculum, which then enabled the animal to move its head above the water, leading into more efficient prey catching. And another feature of Tiktaalik was also a bendable pectoral fin, which was a precursor to tetrapod wrist, and also aided in a better lift and that push out of the water, push up of the animal to come out of the water. Ichthyostega and Acanthostega Both Ichthyostega and Acanthostega acquired distinctive, up until now, refined limb structures, provided superior locomotional length, not fully terrestrial yet, but they possessed four defined limbs with digits, which were the key features. Minor differentiation between those two. One, Ichthyostega had 7, Acanthostega had 8 digits, and some changes in vertebrae column, as well as one had reduced tail and the other one did not. Reptiliomorphs. Reptiliomorphs' evolutionary characteristics gave the rise to modern amniotes, and reptiliomorphs are considered stem amniotes, moving from semi-aquatic environments to completely terrestrial. That is the most differentiation feature of reptiliomorphs. They had stronger and more defined limbs, which aided in persistent locomotion. Still retained gills, but were able to breathe through lungs, more developed lungs. Amphibians, frogs, salamanders, and caecilians. Although amphibians are not the first tetrapods, but more likely considered the group of diverge into ultimately becoming amniotes and the ancestors to modern reptilia. Moving from semi-aquatic environments, amphibians develop adaptations that were key to living on land, such strong limbs and a more rigid skeleton to further support their weight outside the water. Amniotes. The evolution of amniotic egg has enabled animals to move further away from water into land. They were able to lay their eggs in nests and be further out of the water, terrestrial, into more land. Their key adaptive characteristics were linked to locomotory and ventilatory muscles, now dislocated and separated, but harmoniously working together, providing better adaptive qualities to locomotion. And due to these distinctive adaptations, derived synapsids became ancestral to modern mammals. Turtles. Turtles often are considered a clade of its own. They depends on the habitat they live, because they live in various habitats, from marines to terrestrial to semi-terrestrials. They have different characteristics and different limb structure depending on the habitat that they live in. Some are more stoned out to press on land, and some are more expanded for ability to swim. Another characteristic is the shell made of carpus and plastron, which also varies based on the residing habitat of the animal. Hinnerpatten, an early tetrapod, was my choice of an early tetrapod animal for this module. Similar to Ikthalic, primary aquatic, gain ability to crawl out of the water using strong forelimbs resembling today's limbs. It had ability to breathe air from lungs, giving it an advantage to explore the regions beyond water. Non-avian air reptiles, squamates. Squamates are one of the largest groups of non-avian reptiles that include all snakes and lizards. Intense evolutionary transition in morphology are assumed to adaptive in new habitats. Snake's limbless body is generally hypothesized to facilitate locomotion in phosphorial and cluttered habitats. So the references, and thank you.